we're going to spend some time simplifying more expressions. This time, we're looking at how to handle combining like terms and distributing inside the same expression. So before we start looking at some examples and working through the process, we do need to review the order of operations. One thing to always remember is that when you're simplifying expressions, always follow the order of operations. So again, when you're simplifying expressions, always follow the order of operations. Now, there will be some things that are now included in the order of operations that you may not have seen before or knew about, but we're not changing the order. We're not doing anything but now putting some of the new things you've learned and deciding where do they fit in the order of operations. But again, when you're simplifying, we always follow the order of operations. So with grouping symbols, we have parentheses, brackets, expressions in a fraction, and we're only going to work the grouping symbols if it's possible. And here's what I mean. We already know what parentheses look like, right? Brackets you've seen. Brackets are used when there are multiple grouping symbols, like you might see something like this. So brackets would be used when we have multiple sets of grouping symbols, right? Expressions in a fraction, you might have seen something like this in the past, where you have operations happening in the numerator and in the denominator. That's actually considered a grouping symbol. You would simplify the numerator and then simplify the denominator. Okay, so we've seen all those things before. The most important part of this section is to remember that you only simplify the grouping symbol if possible. Here's what I mean. You've seen something like this, right? And we've already talked about this when we learned the distributive property. I can't add x plus 3, so I look outside and I distribute the 2. You've been told to do that. And the reason we do that is because we physically cannot add x plus 3. So the whole goal of telling you only if possible is to remind you not to force anything. Up to this point, anytime you saw parentheses, you felt the need to add what was inside or do the operation inside of the parentheses and keep doing those operations until you eliminated the parentheses. And that's true until now, where we physically cannot do anything inside these parentheses. Don't force x plus 3 to become something else because it can't. I cannot add x plus 3. Don't force it. It's like when you were little and you had that box that had a square and a star and a circle and a triangle, and you dump the pieces out, and then you would put the star into the star's hole, a triangle into the triangle hole, right? Well, before you knew all that, you were trying to stick the star into the square hole and the triangle into the star hole, and you couldn't do it. And it got frustrating because you were trying to force a shape into a place it did not belong. Don't do that here. Don't force it. Do not force x plus 3 to become something else. Okay? That's the number one thing for you to learn for the grouping symbol section. If you can do something, do it. If you can't, don't force it. The next step are exponents. With what we're doing right now, you won't really see anything crazy with exponents. You'll really only see it when you're combining like terms right now. We'll handle operations with exponents later. For right now, what you need to remember is you can only simplify if the base is a number. This does not change. This is true. It's just that right now, you won't really have to worry about exponents so much. Let's do a quick review. Oops. 4 squared. The number 4 is the base. The 2 is the exponent. This would simplify to 16, right? 4 times 4. So when you see a number with an exponent, our natural reaction is to simplify it. 4 times 4 equals 16. Well, if I have x squared, I cannot make x squared become anything but x squared. It cannot be simplified. There's nothing I can do. I don't know what x is. It doesn't matter what x is. If you try to do something, you get x times x, but that's not simplified. That's not a simplified answer. So we only simplify if the base is a number. So if you see that, do it. But if you have a variable for the base, there's nothing to do. Next up is multiplication and division. We know that we work left to right. That's the big one. But I want you to realize that the distributive property that we've been doing, that falls under the multiply and divide section of the order of operations. Because if you think about it, when you distribute a number, you end up multiplying that number, right? Here's what I mean. You know, if we think through the order of operations, our first step is the grouping symbols. I cannot add x plus 1. I don't have any exponents. So once I get to the multiply and divide portion of the order of operations, as I go through the problem, I notice this 4 right next to the parentheses means multiply. And what we do is we say 4 times x plus 4 times 1. I have multiplication here. That's why the distributive property falls under the multiply and divide section of the order of operations. So let's not forget that. I don't want you to wonder, how do I know when I'm supposed to distribute? You distribute when you get to the multiplication part of the order of operations. Simple as that. And when you think of it like that, everything becomes a little more clear. Adding and subtracting. Again, we work left to right. Our second little check mark is actually kind of a pro tip. Additive inverse eliminates subtraction. I'm going to get back to that in a minute. The third thing that's important about adding and subtracting when it comes to the order of operations, combining like terms. Remember, the word combine means to add. So the combining like terms portion of your work happens during the addition step of the order of operations, because combining is adding. Now, this additive inverse is not a step in the order of operations. The additive inverse is something we do at first just to clean up our problem. It's like a spot check. You get your first problem, you just look to see, do I have to do the additive inverse? So it's technically not a part of the order of operations. It's something that you do to set your problem up. Okay. However, by doing that, you eliminate subtraction, which means the fourth step of the order of operations is just adding, which is really nice. Kind of takes out an operation a little bit. So this is just kind of like a side note pro tip type thing. Actually. And there really aren't any side notes for that. Okay, so let's just jump straight into some examples. So copy down example number 1, draw your T-chart. And again, the additive inverse is not in the order of operations. It's something we do to set up our problem and set ourselves up for success. You might feel comfortable with subtraction now, but once we start creating larger problems, if you're not in the habit of doing the additive inverse right away, you're going to start getting things confused. You're going to start making errors, and doing the additive inverse first will set you up to avoid errors. You want to skip a step, you're risking having an incorrect answer. You do this step and it's one better chance of getting the right answer. So the first thing I'm going to do is go through my problem, and wherever I see subtraction, I'm going to change it to addition. We're also to the point where you can start eliminating some steps, eliminating some of the explanations to the side. So I'm just going to call that inverse because it's an inverse operation. So now we go through the order of operations. It's the next goal. Grouping symbols. Can I add 4a plus negative 10? No. Step 1's done. Step 2, exponents. I have none. Step 2 is done. Step 3, multiply and divide. So now I go through from left to right, and the minute I see multiplication or division, I'm going to complete it. So the very first thing I see this 8 that I can now distribute inside my parentheses. The 8 does not go to everything. Remember, the 8 gets distributed to what's inside the grouping symbols. So I have 8 times 4a plus 8 times negative 10. Now here's another point where we can adjust our work. If you need to have the step where you show the multiplication, you can. Don't copy this down, but if you need to show this step, and call it distribute, you can. This is the point where if you're comfortable multiplying in your head, I'm okay with that. 8 times 4a is 32a. 8 times negative 10 is negative 80. And we'll call this distribute. Now, if you like the longer version where you show your multiplication, your next step explanation would just be multiply. But in this case, we did the multiplication in our head. So we distribute. Now, the next step, again, is where you can make some decisions. If you would like to add the step for commutative property, if you want to rearrange so that your like terms are together, so, let's say I circle my variables, put a rectangle around my constant. So if you would like to include a step where you commute and get the like terms together, do that and call it commutative. If you don't feel like you have to do that step, you don't have to do that step now. Now I can look and say, well, I have a 32a and a 7a becomes 39a plus negative 80. Combine like terms. This is the only one you can abbreviate. You can abbreviate to CLT. The only thing is, you can't call it CLT. You have to call it combining like terms. So you have to call it combining like terms, but you can write CLT down. So you can notice here, other than my little setup step, distributing is multiplication, combining like terms is addition. That's the order of operations. You multiply before you add. Easy. Let's look at another example. Again, the very first step is the inverse. And I'm just going to go through and rewrite my problem, changing any subtraction into addition and writing the opposite of the next number. So now I start my order of operations, grouping symbols. Well, I have a grouping symbol here. I cannot add anything inside. I do have parentheses at the very end, but that's not grouping operations together. That's just separating the negative sign from the addition sign. So that doesn't count. I have no exponents, so I go to multiplication. So I'm just going to work left to right and find a multiplication problem that I can complete. And I see it right here, this 2. I can distribute that 2 inside the parentheses. 2 times 12a, 2 times 3. I'm just going to complete the multiplication. I get 6 plus 24a plus negative 20. Because I distributed. Now, I'm going to go find, if I look, I have no more multiplication. I'm all done with the multiplication step. Remember, after you think you complete a step of the order of operations, just double check to make sure you didn't miss any. There's no multiplication I can do. Technically, 24a is multiplying, but there's nothing I can change that to. 24a is as simple as it gets. So now I can go to the adding and subtracting section. I have all addition, so now I can combine like terms because that's what we do when we add. I'll put a rectangle around my constants, put a circle around my variable. If you would like to add a step where you commute, you can do that. Or you can just go straight to 24a plus negative 14 because we combined like terms. Our last example, which is actually example number 3. It's a big one. However, if we take our time and we go through the order of operations, it's not that bad. First step, inverse. Negatives stay negative. The negative p doesn't change because there's no subtraction. Remember, I'm only going to go through and change subtraction to addition. Now, again, it's big, but just relax. Let's look for exponents. I have none. So now we look for multiplying and dividing so that we can distribute. I have no multiplying and dividing until I get to the 9. This 9 will distribute just into the parentheses. It does not distribute to everything. Don't forget that. So when I rewrite my step, I'm going to distribute that 9. I get 9p plus negative 18. Then I just copy the rest of the problem down. I don't do anything to the plus 13 or the plus p right now because all I focused on was distributing. Now, if I look, I have no more multiplication that I can do. All I have is addition. So now we're on step 4, where I look and say, okay, let me see what I can combine. I'm going to draw circles around my variables. That's just my habit. And I will rectangle my constants. Now I have a lot of numbers here, so this might be a point if you feel like you lose track, you're easily distracted, you're a little messy. You may want to add that commutative step in, just so that you can rearrange everything and keep it organized. If you're okay going through it mentally, that's okay too. So one thing I would do if I was you, since I have multiple things here, as you go through and combine, I'd maybe cross things out. So like negative p plus 9p, that's 8p. 8p plus positive p is 9p. The other thing you could have seen was that there was a negative p and a positive p that would cancel, and then I'm left with the 9p. So depending on how clear your writing is, how careful you are, you may want to, cross them off as you combine them, just so you don't leave anything out or miss anything. But we have 9p plus negative 18 plus positive 13 is negative 5, because we combined like terms. And that's it. So again, go through the order of operations nice and slow, double check yourself. You can always look through your steps and just double check that they're in order. If you see combine like terms, then distribute, that means you added before you multiplied and you might have made a mistake. That's it.